let me tell you about two applications that we are very interested in. The first one has to do with agriculture, which is probably the biggest problem that we're facing worldwide. As you well know, 1 in every 7 persons in this earth is malnourished. Most of the land that we can cultivate has already been cultivated. And the efficiency of most systems in the world is improving, but our production system efficiency is actually declining. And that's mostly because of water shortage, crop diseases, climate change, and a couple of other things. So what can robots do? Well, we adopt an approach that's called precision farming in the community. And the basic idea is that we fly aerial robots through orchards, and then we build precision models of individual plants. So just like personalized medicine, while you might imagine wanting to treat every patient individually, what we'd like to do is to build models of individual plants and then tell the farmer what kind of inputs every plant needs. And the inputs in this case being water, fertilizer, and pesticide. And here you'll see robots traveling through an apple orchard, and in a minute you'll see 2 of its companions doing the same thing on the left side. And what they're doing is essentially building a map of the orchard, and in that map is a map, within the map is a map of every plant in this orchard. And let's see what those maps look like. In the next video, you will see the cameras that are being used on this robot. On the top left is essentially a standard color camera. On the left center is an infrared camera, and on the bottom left is a thermal camera. And in the main panel, you're seeing a 3-dimensional reconstruction of every tree in the orchard as the sensors fly right past the trees. So armed with information like this, we can do several things. The first and possibly the most important thing we can do is very simple. Count the number of fruits on every tree. By doing this, you tell the farmer how many trees she has in every tree and allows her to estimate the yield in the orchard, optimizing the production chain downstream. The second thing we can do is take models of plants, construct 3-dimensional reconstructions, and from that estimate the canopy size, and then correlate the canopy size to amount of leaf area on every plant. And this is called the leaf area index. So if you know this leaf area index, you essentially have a measure of how much photosynthesis is possible in every plant, which again tells you how healthy each plant is. By combining visual and infrared information, we can also compute indices such as NDVI. And in this particular case, you can essentially see there are some crops that are not doing as well as other crops. This is easily discernible from imagery, not just visual imagery, but combining both visual imagery and infrared imagery. And then lastly, one thing we're interested in doing is detecting the early onset of chlorosis, and this is in orange trees, which is essentially seen by yellowing of leaves, but robots flying overhead can easily spot this autonomously and then report to the farmer that he or she has a problem in this section of the orchard. So systems like this can really help, and we're projecting yields that can improve by about 10%, and more importantly, decrease the amount of inputs, such as water, by 25% by using aerial robot swarms.